Welcome to This Explainer. Today, we're going to peel back the curtain on the hidden technological ecosystem that safely guides literally millions of people through transit hubs every single day.
So think about the last time you were standing on a packed platform, shoulder to shoulder with hundreds of other commuters. Did you ever stop to ask yourself, how does this organized chaos actually function without descending into total disaster? Well, spoiler alert, it's not magic. It is highly complex, rigorous systems engineering operating entirely behind the scenes. Here's our roadmap for today. We'll start with the high-density transit challenge, move on to the single source of truth, then designing effective audio-visuals, security and crowd control, and finally, station management systems.
Okay, part 1, the high-density transit challenge.
Right off the bat, the macro-level problem we're solving for here is extreme density. Unlike traditional main lines, which typically involve longer journeys and, lower passenger densities at stations, metros are a whole different beast. They carry massive numbers of people over very short distances. Because of this, managing passenger flow safely is an absolutely critical capacity constraint. Think about it. When a metro runs high-frequency services, say over 30 trains an hour, station dwell times have to be incredibly short. The platform is essentially a massive bottleneck. That's exactly why terminal station layouts are designed specifically to deliver rapid train turnarounds. That physical platform space is a major constraint on the entire line's capacity.
To manage this level of extreme density, control systems have to be explicitly designed to handle 4 distinct states of operation. It's not just about your everyday normal operations. These systems actually have to absorb abnormal external stresses, stuff like unexpectedly massive crowds or severe weather. Then there's degraded mode. This is where a system failure puts extra stress on human operators who are trying to maintain safety. And finally, emergency mode, which represents an absolute danger to life, like a fire or a train incident. The technologies we're going to explore have to function absolutely flawlessly across all 4 of these modes.
Moving on to part 2, the single source of truth.
Now, visual passenger information systems provide a vital single source of truth for the crowd. Historically, these literally started as hand-painted boards, which then migrated to those clunky mechanical revolving flap displays. But today's modern LED displays, they pull dynamic, real-time data directly from central control, usually over Ethernet or Wi-Fi. They're tied right into the core train describer and timetable systems so that everyone standing on that platform is getting the exact same information at the exact same time.
But here's a really interesting paradox. What happens when the trains stop moving? As this quote highlights, displaying accurate information becomes incredibly difficult precisely when passengers needed the absolute most. If the trains aren't moving, the automated data just stops updating normally. And this is exactly why having dynamic, integrated communication systems that control operators can manually update is absolutely vital. It's what stops a crowded platform from turning into an agitated, unpredictable mob.
Let's look at part 3, designing effective audio visuals. We've all been there. A badly designed sound system will quickly annoy customers. But worse than that, it can actually become a severe safety hazard if critical messages are misunderstood. So, competent sound engineers enforce 4 very strict requirements for public address, or PA systems. First, a comfortable sound pressure level. It has to be loud enough for passengers, but not so loud it causes noise pollution for the neighbors. Second, clear intelligibility, so the message is actually understood. Third, it really needs to sound like a reassuring human voice, rather than some robotic glitch. And fourth, it absolutely must be accessible to everyone.
And catering to all passengers simultaneously is a huge part of the design. Just look at visual displays for a second. Notice how the text uses both upper and lowercase letters with proper descenders on letters like Y and G? Well, it turns out it's simply easier for the human brain to read that quickly compared to all caps. And paired with that visual clarity, we have hardware like inductive loops, which you can see indicated by that blue sign. These broadcast the audio announcements directly to hearing aids. It's a totally comprehensive, inclusive approach to keeping the crowd informed. Now, when things transition into a true emergency mode, say a station fire, standard announcements get thrown out the window and yield to PAVA systems. Public address voice alarms are a completely different tier of technology. Because their whole job is to safely coordinate a mass evacuation, they require special fire-safe wiring, uninterruptible auxiliary power sources, and total building coverage. Even if the main power fails, or if there's crazy environmental interference like a lightning strike, the PAVA system literally has to keep working to credibly guide people to safety.
All right, part 4, security and crowd control. Modern railway surveillance has evolved dramatically over the years. We've mostly ditched those older, grainy analog coaxial cables for high-quality digital Internet Protocol or IP video.
These advanced cameras throw a multi-layered security net right over the station. They are crucial for assisting with general station operations, managing crowds, deterring crime and terrorism, and, of course, providing high-quality, easily replayable evidence if an incident does happen to occur.
But the real game changer here is the shift from human observation to automated intelligence. Instead of relying on a tired operator to stare at 100 screens simultaneously, which is basically impossible, modern systems use video analytics. This acts as an automated force multiplier. It instantly flags unusual movements within a normally static picture in near real time, drastically reducing the need for constant, unbroken human concentration. And these analytics actually solve highly specific environmental hazards. They allow operators to proactively respond to platform overcrowding, detect perimeter intrusions, or just maintain general situational awareness before a minor hiccup escalates into a full-blown emergency. They could even count footfall to help commercialize retail spaces or optimize how passengers load onto trains. It's really about proactive rather than reactive security.
Which brings us to our final section, Part 5, Station Management Systems, or SMS.
Traditionally, a control room desk was kind of a nightmare. You're talking separate screens for CCTV, separate microphones for the PA, and totally separate computer terminals for the timetable. The station management system takes all of that and collapses it into one single, user-friendly environment. Let's trace an automated workflow here. If a fire alarm trips, the SMS instantly alerts the operator, automatically throws the correct CCTV cameras covering that exact area onto the main screen, and allows for the immediate, coordinated triggering of the PAVA audio and visual display warnings. While there are definitely technical hurdles to integrating systems from different suppliers, doing it this way completely removes the panic and delay of fumbling between different systems during a crisis.
So now that you understand the sheer scale of the incredible systems engineering surrounding you, from the carefully designed fonts on the departure boards to the intelligent analytics in the cameras, all tied together by this integrated station brain, I challenge you to look up on your commute tomorrow. Will you finally see the invisible conductor orchestrating your safe journey? Thanks for tuning into this explainer, and definitely keep an eye out for the hidden systems running our world.